Hello my dear students, welcome to computer science class. Let us continue with our chapter overview of computer. So before we proceed in this video class, let us have a quick glance on what topics we have discussed in our previous video class. So here we have discussed what is computer. Computer is an automatic electronic machine that can store, retrieve and process the data. Then we have discussed what is data and information. The data is the collection of unprocessed items. We can refer it as data, or you can even refer it as raw facts or the figures, which it has to undergo the processing. What is information? Information is nothing but it is the computer processed data. We can refer it as an information that provides some useful information to the people. So based upon that, the people can make certain decisions. What is hardware and software? Hardware is the physical components of a computer system. We can refer as an hardware. Some of the examples like monitors, speakers, printers, mouse, keyboard. Okay, what is the software then? Software refers to the set of instructions or the programs that tell the hardware what operations has to be performed. Then we have also seen the categories of software, that is system software and application software. So system software is a one which consists of programs that would control or maintain the operations of the computer and its devices. Example, operating system. Okay, it could be any operating system, Linux, Unix, Windows XP. Okay, then what is an application software? It consists of the programs that designed to make the users more productive way so that they could assist them in their personal task. That means, for example, if you click any picture and if you want to edit that picture, you may use some of the applications like Adobe Photoshop. You may use it. By using that application, you may edit the photo, so you may get the more clear picture. So that Adobe Photoshop is an application software that is helping the user in order to perform their personal task. They want to get the fine clear picture. So such examples are the application software. Then we have discussed various characteristics of computer. The first was we discussed was speed, next memory, storage, okay, accuracy, versatility, diligence, automation and cost effectiveness. Then we have discussed lastly the functionality performed by the computer. So any computer should be capable of accepting the data and programs as the input, and it should be capable of storing and recall those data and the instruction as and when it is required. And thirdly, it should have the capability to process the data and converts the data into useful information. Finally, that information what is being generated has to be communicated appropriately through the output devices. So these were the topics we had covered in our previous video class. So in today's video class, let us discuss the block diagram of computer system. So based upon the functionalities of the computer system, the entire computer system, which consists of hardware components, are being classified into four main units. The first main unit here is the input unit. Then we have the memory unit, and then the processing unit and the output unit. So these are the four main units that the computer system consists of. Let us discuss here one by one unit. The first unit is input unit. Input unit is a kind of unit which will allow the user to enter the data into the computer system. Whether it might be the data, program or any instruction it might be. So through any one of the input devices, the computer will allow the user to enter the data into the computer system. Some of the examples of input devices might be the keyboard, mouse, okay, scanner, microphone and webcam. Next, here we are going to discuss about the CPU, that is processing unit. CPU stands for Central Processing Unit. So this CPUs will act as a main part of the computer system. It is called as the brain of the computer system because this is the only unit that can read, interpret and execute the instructions systematically. So In the sense, read in the sense, whatever the data you are going to enter through the input unit, that will be read by the CPU, and after reading it will interpret. Interpret in the sense it will understand, and after understanding it will execute. Execute in the sense it will process the data as per the given instructions. Therefore, the CPU is being considered as the brain of the computer system. Alright, now let us take an example. We are going to enter the data here as 5 plus 6. Now 5 plus 6 is in raw data. Through the input device, maybe through the keyboard, I'm going to enter this particular data. Once we enter the data, that data will reach to the processing unit. So this processing unit will read that 5 plus 6 as an instruction, and it will understand the operation. What it has to perform is addition, and after addition it will execute. In a sense, it will process and generate the information out of it. Therefore, the CPU is being referred to as the brain of the computer system. Apart from this, the CPU will make all the major decisions. It will take and performs all sorts of calculations like arithmetic, relational calculations, logical calculation, and it also activates and controls the operations of different units. CPU will control and activates the operations of different units, in the sense it will control input unit, it will control the memory unit, it will also control the output unit. Okay, therefore we can say the CPU will control and coordinates all the actions of the entire computer system. Now let me briefly explain how the data will be processed by the CPU. See, through the input device, once the program has been entered into the input unit, that data will first reach to the memory unit. So that is, it reaches to the primary storage, that is RAM, that is random access memory. Okay, wherein the data will be stored temporarily. Already we have discussed memory as one of the characteristics of computer. See, as in when you give the data will first reach to the primary storage, that is random access memory. So therein the data will be stored temporarily. Once the data is being provided from memory unit, the data will be provided for the CPU for the processing purpose. Now, once the data is being received by the CPU, it will start performing the calculation as per the given instruction in order to perform the specific task. Now, when you give the data as 5 plus 6, that 5 plus 6 will reach to the RAM here, and then from memory unit, that is random access memory, it will reach to the CPU. CPU will read it, interpret it, and it will perform the addition, specific task, in the sense it will perform the addition as the task. And after it perform the calculations, it will even communicate with the other components also of the computer system. Why it has to communicate with the other components of computer system? Because this central processing unit will provide an instruction to the output unit, so that whatever the output is being generated has to be communicated, has to be displayed onto the output device like monitor. As an information it has to display. So this processing unit will communicate with the other components of the computer system. I hope you are able to understand. Now, how exactly this communication takes place? Okay, there is a pathway called as bus. Through that bus, the data will be transferred between the different parts of the computer system. Can you see these lines? See here, this actually shows you the data for arrow what you are seeing. This shows actually the data flow. And what a dotted lines you can see here, this actually shows the control flow. See, the data will be entered through input unit, then the data will reach to the primary. If you want to store it in the secondary storage devices, then you can move the data. A copy of that data will be stored in your pen drives or your CD, or maybe your external hard disk, maybe your secondary storage devices. Therein you can store it. If you doesn't want to have the store in the secondary storage devices, then definitely if it needs any calculation, the data will be passed on to this particular CPU for the processing. And once the data is being processed, again the final result will be sent to the random access memory, that is memory unit only. Then from the memory unit, the output will go to the output unit through one of the any output devices. The maybe the output devices like printer or the speakers or the monitors. Through that, the information, that is processed data, we call it as information, right? Information will be displayed to the user. Now here, what dotted lines you can see, this indicates the control flow. That means this CPU, as I said, it controls and coordinates the activities of entire computer system. Means CPU is actually controlling the input unit. CPU is controlling the memory unit. CPU, it is the one which will give the instruction to the output unit in order to display the output. Therefore, this particular CPU will control and coordinates the entire actions of the computer system. I hope you are understanding the working of CPU. Now, this CPU consists of 3 units. One is memory unit, okay, which can also be referred to as registers, okay. Then it also consists of ALU, that is arithmetic and logical unit, then the control unit. Now we shall discuss in brief what is memory unit. Okay, so herein I'll be showing you, this is all about the input devices, input unit what we have discussed. So these are the few of the examples of input devices. You can see the touch screen, camera, scanner, microphone, joystick, webcam, trackball, keyboard, mouse. Through this you can enter the data into the computer system. Alright, then so these were the points which I have discussed now about the CPU. Okay, then here comes the memory unit. This memory unit, this is how exactly the data will be stored in the computer memory, wherein the computer will store the data in terms of binary digits, that is in terms of zeros and ones. Computer cannot understand any language like English language. It cannot understand the numbers is 1 to 3. It cannot understand the alphabets like A, B, C, D. It can understand only the binary language wherein the data is in terms of only zeros and ones. Therefore, the memory unit in the computer, okay, which is also called as primary storage, and primary storage can also be referred as main memory. Main memory can also be referred as random access memory. As per this particular block diagram, as I showed here, so this we are discussing about this memory unit. Okay, this primary storage can also be referred as main memory. It can also be referred as random access memory, that is RAM. This memory unit consists of thousands of cells which are called as storage location. So this is being referred to as the cells, children, and these cells can also be referred as storage location. So this memory unit consists of number of cells, okay, which are being referred to as storage location, that makes use of binary digits, that is in terms of zeros and ones. So each one of the cell will be identify it with a cell address, that is location in the sense cell address. So in the memory unit, okay, we can store the data, programs, okay, instructions. We can even store the intermediate results, okay, and even the final output. But here we can store the data temporarily. That means the data or the information will be lost when there is no power supply. This nature we call it as volatile in nature. Whatever we store it in the memory unit, okay, the data will be stored temporarily. Until your computer system is on, the memory unit will hold your data. Once the computer system is off, the entire contents in the main memory will be erased. This nature we call it as volatile in nature. Herein, as I said, this primary memory or the main memory can store the data, programs, whatever you are sending through the input unit. Plus, it can also store the intermediate results, I said. Maybe if you have a complex calculations like 5 plus 6 into 3. So this is one entire instruction, 5 plus 6 into 3. As per we know Bodmer's rule, first we need to apply the multiplication, then we have to perform the addition. So those instructions will be given to the control unit. Control unit will divide it So step by step it will divide. Step by step in the sense 6 into 3 will be first calculated. It will be given to the ALU. ALU will calculate, and that intermediate result 6 into 3 might be stored in the primary unit. Okay, then it will calculate again 5 plus. Okay, then we have, so 6 into 3 will be calculated, then it will be added with the 5. So then the final result will be generated. Once the final result will be generated, that will be stored in primary storage. So whatever the content is stored, it will be stored temporarily. See, if the data and programs are being stored temporarily, we should also require to store the data permanently. If at all, if you want to store the data permanently, then we should depend upon the secondary storage devices, wherein it can store your data permanently for the future purpose. Next, here we are going to discuss about the ALU, that is arithmetic and logical unit. So ALU is the unit where all the arithmetic operations like addition, subtraction, division, multiplication and relational operations like less than, equal to, greater than, less than or equal to, okay, and logical functions like and, or, not. So and in the sense where both the condition has to be true. Say for an example, say if a person is age is greater than 18, this is my first condition, age should be greater than 18. Then second condition, he should be citizen of India. Then if age is greater than 18 and he is a citizen of India, then he is eligible to vote. That means both the condition, if it is satisfying, then I'll be getting the result as true. Suppose if the person is age is not greater than 18 but he is a citizen of India, then he is not eligible to vote. So such a decision making statements, okay, we can refer it as logical operations. And is one operation where it has to satisfy compulsory. If both the conditions is true, the overall result will be true. Similarly, OR operation is a one operation where either of the condition, if it is satisfying, then it will be the overall result will be true. Like if the age is not greater than 18, if the age is 17 also, but he is a citizen of India, then he is eligible to vote. So such decision making operations, it has to be performed, then it will be performed by the ALU. Apart from that, even the non-numeric data such as true or false based calculations it has to perform, all such operations will be performed by the ALU. Now let us understand here. Once the data is been fed into the main memory, see, as the input data is given, the data will be fed into the main memory from the input devices. The data will be directly sent to the ALU for the processing purpose. During processes, if any intermediate results are being generated, then they are being placed for some time in the memory unit for temporarily. So therefore, there will be a movement of data between the memory unit and the ALU many times until the processing is being finalized. That means processing is finalized in the sense until the final output is being generated, the intermediate results might be stored in the memory unit, and there may be several time exchange of data may take place between the ALU and the memory unit until the output is finally generated. So this is how exactly the ALU will work. Next, we shall discuss about the control unit. Control unit will act as an central nervous system. Why it is acting as central nervous system? Because it ensures whatever the instructions or whatever the information is there, it will look after that the information is being stored correctly, and it will also see that instructions are being followed in a proper sequence. Suppose if you are giving any complex mathematical operations based upon the rules, okay, based upon how the instructions are being given, this control unit, it will break down the entire instruction into series of logical steps. It will divide, and then each by each instructions it will provide to the ALU and sees to that all the instructions are being executed correctly and even the data is being stored correctly. Therefore, the control unit will control all the hardware operations. So it will control all the hardware operations of different components. It will control the input unit, it will control the memory unit, as well as it will even control the output unit as well as the processor. Therefore, we can call the control unit to be as the central nervous system of the computer system. Next, we are going to discuss about the storage unit. So, storage unit consists of secondary storage devices, which we also refer it as auxiliary memory devices. Okay, so here in secondary storage devices, they store the results which are being obtained after the processing. Suppose if you want to store the data permanently, as we know here, the primary memory will hold the data temporarily. Definitely we will be in need to provide certain, suppose if we want to have a backup of that particular storage, then we should depend upon the secondary storages, which are also being referred to as the auxiliary memory devices. Secondary storage devices can be any USB flash drive, your CD drive, okay, or DVD it might be, or any external hard disk it might be, or it might be the memory cards, okay. So these secondary devices can store more amount of data when you are comparing with the main memory, and they are very less expensive. Next unit we shall discuss is about the output unit. This output unit consists of the hardware components that conveys the information to one or more people in an user understandable form. So what do you mean by user understandable form? In the sense, as I said, the computer can understand the only binary language, that is in terms of zeros and ones. Okay, suppose if the output has been displayed entirely in terms of zeros and ones, it is difficult for the common people to understand. Okay, so whatever the language you are using to give as the input, so within the same understandable form, within the same language, you should get the information. Therefore, it is the responsibility of the input unit to provide the information in an user understandable form. Some of the examples of output devices are monitor, speakers and printers. I hope the explanation regarding the block diagram of computer is clear. Here you can see, students, some of the examples of secondary storage devices, that is floppy disk, hard disk, okay, memory cards, USB flash drive, that is universal serial bus, DVD and CD. And some of the examples of output devices here are speakers, printers, monitors, headphones and LCD. So these are the examples of output devices. Let us continue with the next topic, that is evolution of computers. So before the computers had come into existence, there are various computing devices had come earlier. Now let us discuss one by one. The first one is, we are going to discuss about the abacus. In the year of 2500 BC, that is before Christ, the abacus had come into existence. So this abacus has been known as the first ever calculating machine, which was being extensively used for the counting purpose. So if you clearly observe this abacus is actually made up of beads. So these, what you can see here, these are the beads actually. It is made up of beads that are strung on the cords. These are said to be as cords here. Okay, so beads are being strung on the cords, in the sense beads are being placed on the cords. So this abacus is extensively used to perform the arithmetic calculations. Initially it was being developed for the counting purpose and to perform some simple arithmetic calculations, but now the abacus, using abacus we can even perform the complex calculations. So herein the chords were actually representing the positions of decimal digits and the beads actually represents the digits. The chords represents the positions of decimal digits like tens, okay, hundreds, thousands, like that, whereas beads actually represents the numbers. So this abacus was mainly used for the addition, subtraction, division and multiplication. Apart from this, even we can perform some complex calculations also. You can see here this entire thing, we call it as a frame here. These are referred to as an upper beads, okay. Then you can see these are actually referred to as rod, that is we can call it as chords here, okay, which have been representing the decimal position digits. All right, so this you can see units place, like that, it actually represents the decimal position. Okay, so here in the evolution of computer, we will be discussing the various computing devices. Here we should mainly concentrate that what is the device in which year it has come into existence, and using that why the device was being developed. Next we are going to discuss about the Napier's bones. So in 1614 AD, the Napier's bones had come into existence. Okay, this Napier bones were been actually invented by the John Napier. This Napier's bone was invented by a Scottish mathematician known as John Napier. So here if you look at, you can see this Napier's bone. We have totally the 9 rods here, right from 0 to 9. So each one of the rod, okay, it is actually representing the multiplication table. We have 9 rods here. So 1 rod for each digit, which is representing from 1 to 9, and a 0 is a constant rod they are using. If you carefully observe, this is the one multiplication table. This is, if you see, 2 2s are 4, okay, 2 3s are 6, 2 4s are 8, 2 5s are 10. So each one rod is being representing the one multiplication table. So this Napier bones was actually being developed to perform the multiplication, which had come into existence in the 1614 AD, which was being developed by a Scottish mathematician known as John Napier. The next device we are going to discuss is about the slide rule, which had come into existence in the year 1613 AD. So it was being developed by a William Outred. So mainly this slide rule, if you carefully observe, it is being composed by 2 sets of scales which are being adjoined by the some marginal space. If you carefully observe, this is right here. From here to here it is actually the one scale. Here you can see here. This is from here to here. This is one scale. This is another scale. So this one scale and the second scale are being combined with the adjoined by some marginal space over here. So this slide rule was actually based upon one principle. So what was that principle is, the actual distance from the starting point of the rule is directly proportional to the logarithmic of the number printed on this particular rule. So this slide rule was actually based upon one principle. That principle was the actual distance from the starting point of the rule is directly proportional to the logarithm of the number printed on the rule. So this slide rule was mainly invented to perform the multiplication and division based by the method of addition and subtraction. So as I said, here we should mainly concentrate what was the computing device, which year it had come into existence, and mainly for what purpose the computing device had come into existence. Next we are going to discuss about the adding machine known as Pascaline. So this is how the adding machine will look like. So this adding machine is also being referred to as an rotating wheel calculator. Okay, this adding machine is also being called as rotating wheel calculator, which has been developed by a French philosopher known as Blaise Pascal. So Blaise Pascal has devised this machine in the age of 19 itself. So this machine was being named on him, that is, it is also being called as Pascaline. Okay, so if you carefully observe, this adding machine has 8 movable wheels. If you are seeing, these are 8 movable wheels through which you can enter the numbers. So if you carefully observe here, actually here some numbers are being printed by using these 8 movable wheels, and these wheels are actually being referred to as dials. Okay, the numbers were entered into this machine by using these dials, and this adding machine was used mainly, it was being developed to perform the addition, subtraction, division and multiplication by using the gears and levers. So this machine was able to calculate with the bigger numbers in terms of thousands actually. So this adding machine laid the foundation for the today's electronic calculator. So this adding machine, which is also called as rotating wheel calculator, and it has been named after Blaise Pascal, called as Pascaline. So these were some of the devices we have discussed. We have few more computing devices to be discussed. We shall discuss in our next video class. Thank you, students.